Okay, so in this video we're going to go over chapter 4.4, which are the laws of logarithms. So we have our product rule, our quotient rule, and our power rule. So let a be a positive number with a not equal to 1, so a is our base. And let a, b, and c be any real numbers with a be greater than 0. So our first one is the product rule. So if we have log a, where we have a and b that are multiplied together, then we could split this up and we'll have log of a plus log of a, b. So we're splitting up this multiplication into addition into two separate logs. And then our quotient rules, we have log of a with a over b, and that's equal to log of a minus log of a, b. So we're changing this division into subtraction and splitting the logs. And then we have the power rule. So we have log of a with a to the c power equals c log of a to the a. So we move this c to the front, we move the exponent to the front. Okay, so for example, we have evaluate log of 4(2) plus log 4(32). So we can use our product rule. So we have two separate logs with the same base. So we could go ahead and multiply 2 and 32. So we put those together. So we have log of 4 of 64 equals 3, because 4 cubed equals 64. Okay. Now I have log of 2, 80, minus log of 2, 5. So that's subtraction, so I could use my quotient rule because they have the same base. So I have log of 2 with 80 divided by 5. So it's log 2, 16, which equals 4, because 2 to the 4th equals 16. And then I have negative 1/3 log 8 equals log, and then I move the negative 1/3 to the 8 because that's our power rule. So I have log 8 to negative 1/3, which is log 1/2, which is approximately negative 0.301 on the calculator. Okay, so now I'm going to use my rules to expand these expressions. So I have log of b x squared times the square root of y. So I changed the square root of y just to y of 1/2, so it's easier to deal with. So here I have a product, and I want to expand. So I could change this product into addition. So I have log b x squared plus log b y of 1/2. And now I want to expand further, so I use the power rule to bring my powers up front. So our final answer is 2 log bx plus 1/2 log by. Okay, now I want to expand this expression. So I have log of 6 cube root of x over 36y to the 4th. So I want to expand it. So the first thing I do is I'm going to change the cube, the cube root of x to the 1/3. And this is division, so I could expand by making it into subtraction. So I do that. Now I can go ahead. I look at the inside. This is a power rule. This is a product rule. I have 36 times y to the 4th. So I could go ahead and split this section using my product rule. So I'm going to have log of 6 x to 1/3 minus this whole thing. So make sure you're keeping your parentheses because this minus is to the whole thing. Sometimes you guys don't add the parentheses and you guys just think the negative belongs to log 636. Make sure it belongs to everything though. So we have log of 636 plus log of 6 y to the 4th. And then now I could go ahead and do my power rule. So I move the 1/3 to the front. I have 1/3 log 6x minus log 636 plus I move the 4 to the front. So I have 4 log 6y. And now I'm just distribute the negative. So I have 1/3 log 6x minus log 636 minus 4 log 6y. And then I could go ahead and evaluate this. So log 6 of 36 is 2 because 6 times 2 is 36. Or 6 squared, sorry, not 6 times 2. Then I have 1/3 log 6x minus 2 minus 4 log 6y. Alright, now we're going to combine and condense log expressions. So now I want to not expand it. So here we were expanding it. Here we want to combine and condense it. So I have 3 log x plus 1/2 log x plus 1. I want to combine these. So I could go ahead and use the power rule, and I moved my 3 back with my x. And then the 1/2 goes all around x plus 1 for the power. And then I could combine this by using my product rule, because I have addition here. So I could go ahead and multiply x cubed and x plus 1 to the 1/2 power. So I have that, and that's all inside my logarithm. Okay. Now I want to combine 3 ln s plus 1/2 ln t minus 4 ln t squared plus 1. So I go ahead and do the power rule. So I have ln s cubed plus ln t to the 1/2 minus ln t squared plus 1 to the 4th. Now I look at this here, and I could do the product rule. So I combine s cubed and t to the 1/2, multiplying them. So I have ln s cubed t 1/2 minus ln t squared plus 1 to the 4th. Now for this whole part, I could do the quotient rule. So I have natural log s cubed times square root t all over t squared plus 1 to the 4th. So here are some common mistakes where I have log a x plus y equals log a x plus log a y. So make sure not to do these. So here people are thinking, oh, I could just split the logs because they're addition, and it has to be product, so it has to be multiplication, so that does not work. The second common mistake is log 6 over log 2, saying, oh, I could just combine the 6 divided by 2 and do the log. No, it has to be log of a over b in order to split it, and that's splitting it using subtraction. And then the next mistake is saying, if I have the whole log 2x cubed, then I could bring the cube up front. Oops, accidentally went to an old note. So that one, it's just if the x has the cube that you could bring it up front. Okay, here's the next example. So we have, if a task is learned at a performance level p0, then after a time interval t, the performance level p satisfies log of p equals log p0 minus c log t plus 1, where c is a constant that depends on the type of task and t is measured in months. Alright, so our first step is we're going to solve for p. So I have log p equals log p0 minus c times log t plus 1. So I'm going to go ahead and basically condense this. So I have where I can move my c to my t plus 1. So I have log p0 minus log t plus 1 to the c power. And then I could do my quotient rule. So I have log of p0 over t plus 1 c. And then I could actually cancel my logs here. So it's log base 10, and I could cancel it because log is a 1-to-1 function, so it has an inverse. So we apply the inverse to both sides, and then I get that cancels the log, so I get p equals p0 over t plus 1 to the c. Alright, so our part B is, if your score on a math test is 90%, what score would you expect to get on a similar test in 2 months? After a year, assume C is 0.2. Okay, so our P0 is 90, C is 0.2, and T is measured in months. So for 2 months, our T equals 2. So I just plug that in. So I have P equals 90 over 2 plus 1, 0.2, and that's approximately 72. And then a year, our t is 12 because it's measured in months. So p equals 90 over 12 plus 1 squared, or to the 0.2, sorry, is approximately 54. Alright, so we have our change of base formula. So I have log of b of x equals log ax over log ab. So here basically we want to change our base to a. And so how I like to remember it is I have log a over log a. Those are just the base that I want to change to. And basically I just remember the x goes on top because the x is higher than b here. So I have x and then the b is lower. So that's how I remember which one goes on top. So for like common logs, we have log of b to the m. If we wanted to change that to base 10, we just have log m over log b. If we wanted to change to the natural log, so we have log b to the m. Changing to the base e, we just have natural log m over natural log b. Alright, so for this example, we're going to use the common change of base to evaluate log of 5 of 140. So I have log 5 of 140 equals log of 140 over log 5, which is approximately 3.07. And then I'm going to use a natural change of base to change log of 9 over 20. So I have natural log of 20 over natural log 9 is approximately 1.36. So the change of base actually comes in handy at sometimes because when we're using our graphing calculator, we don't have a key for like log of 6. So that's when we use the change of base to write log of 6x, and then we could write that as natural log x over natural log 6 because a graphing calculator does have a ln function that we could use to solve and also graph. Alright, I'm going to go ahead and end the video, so I'll see you guys later.